Testing, testing, 1, 2. Okay, and welcome to Voltage Rules. Our rules for today involve how to go through voltage. So let's start off with series. Series, the rule for series is that our voltage in a series must all add up to the total amount of voltage for that series. So we have 12 volts coming into this. So the voltage through the first resistor here, the voltage through the second resistor here, and the voltage through the third resistor here must all add up to the total that's going into that series. Seeing as how, or the total across that series, I should say. Because voltage is across, kind of like you're looking at a friend across the river. You want to see how much work it takes to get to the other side, how hard you'll have to swim. Well, that's similar to voltage. How much effort do you need to put in to get electrons across a resistor or other component? Okay, so in series it was additive across a parallel. We have the voltage 1, 2, and 3 are all equal to each other across a parallel. So each of these is equal to the 12 volts because that's how much was being put in. So how can we combine these rules? Well, we have this thing called the loop rule. The loop rule says that any loop that we create following a wire while we don't start inside of a component must be equal to 0 because voltage is the electron pressure difference. So if we end up back at the same spot, which is what a loop does, it should end up having no difference because it is how it is. So this is the positive side for the battery here, this is the negative side here, because the positive side faces the positive side of the battery over there. And so we have the positive side and negative side here, positive side, negative side here. That's because the current, again, flows this way and goes into each one. Okay. So now that we know which side's positive, which side's negative, we can create a loop. So if we create a loop going like so, we end up with going into the positive side of this resistor here. So I'll call this V1. So positive of V1, and then we hit the negative side of the 9 volts, so minus 9, and we end up back at the same spot, which means this must equal 0. So therefore, if we do a little bit of algebra, we see that V1 must equal 9, and 9 volts, because we always have to put a unit on. And that makes sense with what we know for our parallel rule. Everything in a parallel must be equal to each other, and these two resistors are certainly in parallel because they are the only resistors on their individual branches that were split up by a branching point. Now, we could also find this one up here, V2, if we create a loop that goes... Oh, can't cut through the middle there. It goes like so, though. So we hit the positive side of V2, then we hit the positive side of V1, which we now know to be 9 volts, so it's plus 9. And then we hit the negative side of the battery. Yes, we include the battery in our loop here. And then we reach back at the start, so we end up back at 0. So if we do a little bit of algebra, we end up with V2 equals 3 volts. Now that we know that those two are 3 volts, that's our loop law. Any loop that you create, doesn't matter how you make the loop go, if you start at one point and end up back at the same point, and you use the side of the components that you enter, whether it be positive or negative, as the sign for your voltage, then you'll be fine. So here's a quick example of this. You've got a loop here, and we can create a loop that goes like so. And we get back to this point here. So we start off with a positive 1 volt. We go through the positive side of V1. We end up going through the positive side of 3, going through the positive side of 2, and the negative side of the 12 volt. And that must equal 0. So 1 plus 2 plus 3 gives us 6, minus 12 gives us negative 6. So V1 minus 6 must equal 0, so V1 must equal 6. And we can do that loop again for V2 and for V3, so very similar loops. So we hit 1 plus 4 plus V2 plus 2 minus 12 equals 0. So this makes 7, so that makes it 5, so V2 minus 5 equals 0, so V2 must be 5 volts. And if I make a quick loop here, I can also use my parallel rule to say that V3 equals 5 volts. And that was your quick little reminder as far as how voltage works in parallel and series. See you next time.